Mm, okay, let's go. This is a webinar series from A Priori Technology. This is Emanuele Bassi from Enginesoft Italy. And this webinar is made to give more visibility to the importance of balancing cost and environmental impacts, reducing products' carbon emissions. Today we are here for the third part of this webinar series, and the topic of today is balancing cost and carbon, the importance of sustainable design. Today with us, there's Mark Ashton from A Priori Technology. Thank you so much to joining us once again, Mark.
Thanks for having me, Emmanuel.
I want to remind you to all the attendees that at the end of this presentation done by Mark, there will be a Q&A session. So if you want to ask some questions, please write them in the Q&A panel. So Mark, please, it's up to you, and you can start with your presentation. Thank you so much.
Thanks very much, Emmanuel. So yeah, welcome everybody to the last in the series, but probably not the last altogether. So this is the third week in a row we've done an introduction and an overview of what A Priori can do. If you've missed the previous two, no problem. They're available on demand through the Enginesoft website. But today's session is all around balancing cost and carbon from a design perspective. So we're really going to look at the importance of sustainability when it comes to design. So my name's Mark Rushton. I'm part of the product marketing team at A Priori, responsible for design engineering and sustainability. My background is engineering design. I've spent the best part of 2 decades involved in product development, namely 3D CAD and additive manufacturing and adjacent technologies to those. Started out as a design engineer and then very quickly kind of moved into the software, and I've worked at 2 of the big 4 CAD software vendors, and I was product director for the most well-known 3D CAD software. So fair to say I know a little bit about product development and 3D technologies. I'm currently at A Priori. So A Priori has been around for about 20 years with the mission to really help customers get more from every spend around designing and manufacturing their products, whilst also minimizing the environmental impact. So essentially, we give insights and data to help customers, manufacturers, designers make decisions around what a product should cost, how manufacturable it is, and also the sustainability aspect of it. So our software is really a platform. We've been going for about 20 years. Our headquarters are in just outside Boston in Massachusetts in the US, but we also have offices in the UK, in Belfast, and in Germany as well, in the Munich area. So thousands of people at the world's leading manufacturers rely on A Priori today to bring their products to market profitably and without delays. Some of the customer names on the screen: Danfoss initiated a corporate-wide cost down initiative. A Priori was part of that, and using A Priori, they've reduced their new product introduction cost by around 20 to 30% consistently. Alstom story is another one. Using A Priori, they've implemented their own zero RFQ process. So with the top 15 of their suppliers, their strategic suppliers, using A Priori at both sides, they've agreed all of the costs and all of the figures that go into calculating costs. So they don't have to do an RFQ process. They already know from A Priori how much it's going to cost at each of those suppliers. So it just cuts out that whole process and really speeds up their procurement. So some really interesting things that can be done with A Priori technologies, and it's used at all of the big name manufacturers around the world. Now, some of the top priorities in industrial manufacturing are where we can help as well. So inflation and margin pressure. We've felt it quite hard the last few years in terms of inflation globally, but margin pressure is still a big thing as well. That's something we can really help by giving you a breakdown of where all the costs are coming from when it comes to your products. Supply chain risk, obviously, with the geopolitical environment changing all the time, it can really lead to enhanced supply chain risk. So knowing where to look in different parts of the world, where is it profitable to do so? Where is it reducing the risk? We can help with that kind of assessment as well. Manufacturability skills are something that has been a concern for the industry for at least 15 years. And it's really because 3D CAD is so easy to use these days. You can create any kind of shapes, not all of which are manufacturable. And a recent study that was quoted in Forbes was that whilst the majority of students coming out of university and school are very well versed in 3D CAD, there's much fewer that are actually well prepared to make manufacturable design. So that there is definitely a skills gap there. And our design guidance can help close that gap. And then today's topic is really around sustainability action. Many companies in different sectors have made promises that they're going to reach net zero, but without really knowing how they're going to get there. A lot of organizations are planning big increases in investments around sustainability, and A Priori gives you the insights on where you can make a difference. So we kind of tackle all four of those top priorities. And the way we do it is leverage the investments you've already made in digital twin technology. So a lot of companies have done a pretty nice job focusing on the digital twin of the product. The 3D CAD model is the basis, adding PMI and other metadata, storing it in the PLM system. It's the start of a digital thread. We might use that for some digital prototyping as well, using FEA and CFD and those things. But where A Priori comes in, it's adjacent to simulation technology, but it's simulating the manufacturing process. And it's unlike the other simulation technologies. We do it in seconds and minutes rather than hours and days. And we really bring the digital twin of the manufacturing process within a manufacturing facility. So we bring two digital twins and run the digital twin of the product through the process twin and the factory twin. And by doing that, the insights that you get are the cost, the time to manufacture it, any potential manufacturability issues, but also the amount of carbon emissions as a result of those processes and all the way back to the raw material. So it can really help with your upstream scope 3 reporting requirements. So today we're going to be looking at the importance of sustainability when it comes to design and incorporating that and some of the challenges. Then looking at how you can look to balance cost and carbon, because they're two very different units, really. You know, how much is a kilogram of carbon emissions? What's the damage? What's the increase in risk to your business? What are the potential tax implications? How is it going to harm your bottom line? A customer is going to be put off by emitting extra carbon emissions than what you really need to. All these things come into the equation. So balancing cost and carbon is really a critical one to consider. And then we've got a bunch of sustainable design case studies, and these can be really insightful. Just some of the things you can start to play around with, some of the levers you can pull in order to improve the sustainability and the profitability of every design that you make. And being able to do that early during the design process is where it's most valuable. And then we'll summarize today's session. So as we all know, it's really a global problem, climate change. 20% of the world's carbon emissions come from manufacturing and production sectors, and also 54% of the world's energy consumption. So manufacturers, our customers, are very much responsible for some of the climate change issue, but we also offer part of the solution as well. You know, engineers are going to be the ones that solve this issue if we ever do. And I'm hopeful that we are. So some of the challenges around design and sustainable design is really the lack of knowledge. If you look at two designs, intuitively, you can probably say this one is more expensive than this one because maybe it looks more complex or the quality is better. You've got a good indication of what's more expensive usually, kind of intuitively. But if I was to show you two designs, it would be very difficult for you to kind of guess intuitively which one has a higher embodied carbon in it. Then when it comes to business models, we're really focused on profitability as a business. And usually the way to increase profitability, increase revenue is to sell more. Now, selling more doesn't necessarily mean that your carbon emissions are going to be less. Usually it's the other way around. So our business models don't really work too well for sustainability. So we need to kind of look at balancing the books in a different way. Then when it comes to sustainability team, they're really focused on the reporting, making sure that everything that's been done is accounted for, much like a finance team. When it comes to design, they're not really too focused on the design and manufacturing phase. For the majority of people, the biggest impact to the biggest environmental impact is when the product is being used. If the product uses any kind of energy during its lifetime, that is going to be the biggest proportion. And that's usually where the sustainability team want to focus because that's where you start on the biggest area. But we'll look at that in a bit more detail. It's also where you can potentially have the least impact and the least control. And then the last section is again, the sustainability team is going to be focused on the regulations and the reporting pressure rather than looking at making proactive decisions to reduce carbon up front. So let's take a look at the first one, the lack of knowledge. And it's really like design teams are operating in the dark. Yeah, they have a distinct lack of knowledge and a lack of insights, partly from their tools. So in 3D CAD, there are some DFM checks, but you really need the knowledge to put into those checks for them to be useful. For instance, draft analysis. Obviously, you need draft for cast or injection molded parts, things like that. But how much draft is actually dependent on the size of the model itself. It's often dependent on the material, and it's potentially dependent on the machine that you're using as well, based on the clamp forces and the depth of it. So without that knowledge, the DFM checks in CAD are really kind of lacking. And getting that knowledge either is a lot of time for you to go and find it, or it's learned through experience. And experience tends to be expensive through failures and things like that. When it comes to cost, well, cost estimations don't usually happen while the designer is designing. They usually happen downstream when the designer's moved on to something else, or sometimes it's even the suppliers that are responsible for the cost estimations, giving quotes, and that can be several weeks after the design's finished. And so when it comes to carbon equivalent emissions, it's just an additional pressure and one that nobody really has insights into today. So when it comes to business models, one thing we can do to address the balance is to apply an internal cost of carbon. Now, I spoke about this last week in the sustainable sourcing section, but if you are to quantify the cost of carbon by applying an internal carbon price, like many of the top 500 companies are doing, everything else kind of falls into line. What you're going to want, if you've got a cost of carbon, you are going to want a really accurate idea of how much carbon emissions you're putting out. And so you're going to want more insights. You're going to want more accurate measurements. You're just going to really treat it as a cost that's potentially leaking out of the business. So if you do nothing else, just applying that internal cost of carbon and internal carbon price, that's going to give you a really good strategy for going forwards, because now everyone is just chasing cost, rather than how do we deal with carbon and cost separately or together. And as I said, the sustainability team, they rarely start in design. They tend to look further down. So the design team is responsible for the material selection, the design, the shape of it, the geometry, the thickness, the manufacturing process, because they're kind of dependent on the materials and the design, and vice versa. And maybe the product development team, maybe the sourcing team, has an idea of where it can be located. So as a manufacturer, we've got full control over those four. But the sustainability team tends to focus over here. And that's when it comes to logistics to the customer. So how can we reduce those emissions? Can we reduce the packaging, things like that? And also the biggest area, which can be 70% or more, is the in-use phase. How can we make the product more efficient? How can we get our customers to use renewable energy, things like that? And then how can we capture the product at the end of life and reuse it, recondition it, remanufacture it, or worst case, recycle it? And all of those things are really reliant on the customer, how the product's used, and having that closed loop to get the product back. That's definitely the hardest area to do anything about. The other thing is the in-use phase. If it's an electrified product, you've already kind of decarbonized it as much as possible if you've moved away from fossil fuels. So if you've gone to a synthetic fuel or a low carbon method of powering the product, you can kind of rely on the natural energy transition of the grid. So there's huge investments going into renewable energy, and it's forecast to be 20-30% lower carbon electricity by 2030. That's based on the International Energy Agency. So you can see that those areas that they might be significant, and that's where the sustainability team tend to go to first. But we've got a lot more control over the first four. And as the grid gets greener, those first four are going to become more significant overall. They won't get bigger, but they'll be more significant as a whole. And what we found by talking to customers is there's really four levels of maturity. So the first place to start is creating a baseline. You need something to measure against. A lot of customers choose where they were in 2019 and try to measure the products and corporate sustainability from that year, and they use that as a baseline. And they'll try to make any announcements based on that baseline. So if they're looking to halve their emissions, they'll do it based on that baseline figure. If they're looking to reach net zero, it'll be based on that figure. Then the next place to start is sustainable sourcing, because you're not really having to change the design of the products. You're not having to change any real specifications. You can just look at a more sustainable supplier, one that uses more renewable energy, one that's in a lower carbon energy part of the world, like the Nordics, for instance. They use a lot of wind power, or Brazil, they use a lot of hydroelectricity. So anywhere that uses kind of lower carbon energy generation is a potential route to look for. Then I call it sustainable cost engineering. It could be value engineering or just re-engineering, but taking an existing product and making it more sustainable. So looking at whether you can source some more recycled content. So when it comes to aluminium and steel, there's no real loss of performance with those materials when they're a higher recycled content. They're really 100% recyclable without any loss of performance. So swapping to a greener grade of those materials is quite an easy thing to do. Or you can look at the manufacturing process itself. Can you make it more energy efficient? Can you swap some of the processes to use electrified processes instead of gas-fired and things like that? Or is there anything else you can do? Can you change the process from machining to casting, for instance? Maybe it's a small design change, but nothing too major, and you can get some savings there. And the most mature companies are really considering sustainability from the get-go, from design, and they're really considering everything else along the whole chain. So in terms of maturity, really starting at the end and working backwards. So today we're going to look at the more mature phases. So in the last week's session, we looked at the first couple of stages. We're going to focus on the kind of tweaking existing products and starting from scratch. And to do this, we're using the A Priori Manufacturing Insights platform. And what we do is take the 3D CAD model, we'll run it through a digital factory. That's really the only input that you need to make as a user. We run some automated analysis through our artificial intelligence engine and give you insights to review. And those insights allow you to take action on exactly what you need to take action on based on your requirements. So getting insights into the sustainability, profitability, and the manufacturability of that product gives you a really insightful position to make decisions around.
If you are looking to join the rapidly expanding number of leading manufacturers using A Priori to improve their product profitability, sustainability, and manufacturability, you start by simply uploading your 3D CAD model into the Manufacturing Insights platform. After choosing from a list of manufacturing process groups, a digital factory, and an annual volume for production, you are ready to get insights into cost, carbon, and DFM. In seconds after a full manufacturing simulation, we get design guidance based on a combination of best practices and the specific capabilities of manufacturing facilities. This allows the design to be right the first time, accelerating your time to market, and reducing the back and forth so often required with suppliers. We can also dive deeper and look at the time and cost of each operation, as well as a full breakdown of fully burdened cost, which can be used to drive further reductions during design or leveraged for fact-based negotiations downstream. We can then start to make data-driven decisions earlier in design by comparing different scenarios, altering the design, the material, the manufacturing process, or the chosen supplier or region. We can then take this to the next level of automation by leveraging A Priori's bulk analysis and upload a complete project of 3D CAD assemblies. Or go fully automated and integrate manufacturing insights into your PLM system. Everything evaluated on the Manufacturing Insights platform can be viewed from a much higher level too. Using the inbuilt analytics, we can build dashboards and reports to help us identify opportunities for innovation, applying precious resources on the most impactful areas, reducing risks and focusing efforts. Or use the data for strategic sourcing decisions. On top of all that, scenarios can be shared with key project stakeholders, enabling in-context collaboration with full traceability. Removing the need to schedule time for experts to review designs, getting more profitable, sustainable, manufacturable designs to market faster than ever before.
So that's how it works. And it is a platform. So it's not just for one group of users. It's not just for a single silo. It can really be used across the product development cycle. So you can use it in one area, but it's really most powerful when you use it along the whole process. So design engineers have a view. They can do things earlier on, start to make some reductions. Then it can go to a value engineer and they can take the data that's been generated from the design engineer and refine it, look at things to a much deeper level and do a really nice job of optimizing the manufacturing process. Program managers can view the analytics from a high level and look at where to focus and look where the risks are and where the opportunities are. And then anybody else that has an influence or is a stakeholder in the product can review what's going on between all of those teams and make comments, all in context of 3D with those insights. So we have a name for each kind of area. AP Design is what the designers use. AP Pro is what our experts use. AP Workspace is the collaboration tool. And AP Analytics is our business intelligence platform for creating dashboards and tracking products against cost and carbon. And then AP Generate is what links it to your PLM system. So all of them are kind of optional, really. But AP Generate just automates the whole thing. As you check your designs into PLM, you get an email back with all of the results. So you can really optimize it to a good level. Now, the product development process, we've probably all seen this before, but the earlier you start to make design changes, the more design freedom you have, the more options you've got available to you, and the lower the cost is. So as things progress to the right, the cost of any changes goes up, and you've also got less design freedom as well. So the blue line is the design freedom going down. That's also the same as carbon equivalent emission reduction potential. So those two things decrease in terms of opportunities, whilst the cost of any changes goes up. So we really want to make changes as early on as possible. So today's session is all about balancing cost and carbon. So what levers can we pull there? So we've kind of touched on a few of them already, but it's everything the designer and product development team has influence over. So it's the geometry, it's the shape, it's the material, the manufacturing process, and potentially the location and the energy mix that's being used in that location. So what I want to do is just run through a series of scenarios to show you what a priori came up with, but also how every case is really different, and you can't really apply one rule for every single case. And we're going to make it a little bit interactive as well. So this scenario is part of a train. It's a customer example, and this is kind of one of their demonstration pieces. It's a welded assembly, so lots of sheet metal, formed sheet metal, then welded together into an assembly. And the scenario they gave us was to come up with a lighter weight version with lower environmental impact, potentially lower cost as well. And if you can, reduce the lead time. We don't want it to take longer to manufacture. So we looked at it and thought, oh, we can probably do some part consolidation on this. That was my design head going. So can we do it in one piece, simplify it a little bit? It might be less parts, but it could be more complex. So which do you think is going to be the lowest cost? And this is when we're going to launch a poll question. So I've got two questions. What is going to be the lowest cost, and what is going to be the lowest carbon? So if we can launch those poll questions, out of the two, we've got left-hand side and right-hand side. So what the one on the left is the assembly, the one on the right is the single part version. So Dennis, can you launch the poll? Perfect, thank you. So which will be the lowest cost and which will be the lowest carbon? I just want to get an idea just to see how intuitive that kind of a question is. So if you were presented with these, imagine you're a design manager, you're being shown these two designs, you know the requirements are less cost, less carbon. Which one are you going to go for? And when we've got a few answers, we can take a look at the results. Okay, so both coming out with the single part on top, although a few people choosing the welded assembly as the lowest cost. So let's take a look. Thanks for launching that, Dennis. So this is exactly what we can find out. So our baseline was our sheet metal welded assembly, and it came in around 186 euros, manufactured in France. The weight was 62 kilograms, and it took about 17 minutes to manufacture. So the welding and everything took about 17 minutes, and the carbon emissions was 247 kilograms for that one piece, or for that assembly. So the single part version came in at 161 euros. So we made a saving there. We made a saving on the weight too. And it also brought the time down and the carbon. So if you said both carbon and cost were lower, you were correct. So then you can look a bit further. We can look at the total cost savings if we were to kind of roll this up into an annual amount. And just this one piece, this one assembly consolidated into a part would save around, based on an annual volume of just 300 units, you're saving 7,000 euros. So pretty significant figure. And we're using to give us our internal carbon price, we've got 100 euros per ton of carbon emissions, and that gets rolled into the cost savings. So here's another one. So another question for you all. So we've gone from single part to assembly to single part. We're going to do the opposite way around. So this is an automotive example. It's blurred out because it's a customer part. It's an EV manufacturer, similar kind of constraints really. Lightweighting is essential, but sustainability is also a customer requirement, and perceived quality is something we want to make sure we've got as well. So this time we're going the other way. We're looking at splitting this part into more than one piece, because this is about 3 meters long. So it's a very long piece of trim. It's injection molded, so you're going to need a big machine. So if we create it out of more parts, but smaller parts, which one's going to be the lowest cost and which one's going to be the lowest carbon? However, it gets more complex here because it's not just one piece or two piece. We can cut this into as many pieces as we want. So if we can launch the second poll, we've got a few more options to choose from. Do we want to make this in 2 parts, 3 parts, 4 parts, or one big part? So we've got a lot more to consider, and that's for both cost and carbon. So if you could just launch this second poll question there, Dennis, and we'll see what people's response is to that one. So you can see it's the last one, fairly simple, but as we progress, you know, we're becoming kind of more realistic with our design challenges. We have more options available to us as a designer and manufacturer. So you know, we've got more freedom to do things, and it definitely makes the decision making more critical, but also more complex. So let's see what the result is here. Wonder if any of you are abstaining from voting because it's too complex. So there we go. So the votes are a lot more split on this one. So hopefully you can all see the results on that one. For cost, the majority of people saying the single part was the lowest cost. And the same with carbon, actually. They're both the most popular. And the 2-piece assembly is the next most popular by the look of it. Although a lot of people thinking the 4-piece assembly is the best option for carbon. Very interesting. So let's have a look at the results. So we did do it for all of the versions, but I don't have the answers for all of the versions. But the first one, it was a glass-filled polymer, 30% glass-filled. The 3-meter version was 12 euros 51, came in just under a kilogram, and 7 kilos of carbon emissions. And it took about 4 weeks, manufactured in the UK. So the best option, we tried 2 pieces, 3 pieces, 4 pieces. The best option was 3 pieces. And the reason for that is there are not many machines that can take a 3-meter long part. So what that meant was the clamp force of the machine went up, and therefore it was a much bigger machine, and the energy use during that injection molding process went up as well. So by splitting it into 3, we can actually do a multi-cavity tool and get it on a much lower clamp force and get everything done at the same time. So the weight is the same because we just split it into pieces, but we made a fairly significant saving based on the volume. So assuming 10,000 units of the whole thing, and we saved 24,000 euros. So you can see part consolidation is not the answer. Splitting parts is not always the answer. So the next scenario really gives us a different approach altogether. So this is a light, a kind of fluorescent style light housing. It's probably LED these days. But we've got the 2 end caps that we thought we can probably do something to reduce those. So the initial design was a sheet metal piece, so folded and then clipped into the end, so nice springy piece of sheet metal to clip onto the 2 ends there, and the rest of the body's just extruded. It's a pretty efficient process. So the 2 end pieces we thought we could do something about. So we redesigned it as a plastic injection molded version. So tried to do a 2-piece tool design with some clips in there. We probably need to make it quite a springy polymer to make it somewhat similar to the sheet metal version. So I haven't asked any questions on this one because it's a bit more complex and we've got a few more options to run through. So we started out with a sheet metal version with some chrome plating on there because it's a decorative piece. It's going to be on someone's ceiling. We want it to look nice. We were getting it made in China at a cost of around $1.61. The weight we don't really care too much about because it's just sat on someone's ceiling, but it took 4.63 seconds to manufacture and 2 kilograms of carbon. Changing that to an acetal with chrome plating on did reduce the cost, but the time to produce them went up. So the injection molding process for 1 at a time went up compared to the sheet metal process. Then we tried a nylon. Now the nylon brought the price down. It's just, bear with me 1 second, it's animating by itself. Nylon brought the cost down and the carbon down, but the thing was, we would have to paint to get the finish that we were after, because you can't chrome plate nylon, and that's something that A Priori actually flagged for us. It said it wouldn't be compatible because of the material. So the time went up slightly, but everything else came down. But the fact we would have to paint it meant we kind of scratched that off the list. So the other option to get the time down is to look at a multi-cavity tool. So if we were to put 4 in at the same time, we can actually get the time down by 4 equivalent, because it will still take 12.96 seconds, but because we're making 4 at a time, the equivalent is 3 per part. That's going to bring our carbon emissions down further per part, and then we can look at different regions to actually manufacture it. And this is where the internal carbon price is really useful, because Sweden, Spain and Poland, you can see we've got very different pricing across all of those, but we've also got very different carbon emissions as well. So how do we decide that 800 grams of carbon equivalent emissions and $1.41 is better than half the carbon and double the price? How do you balance those two, or a slightly higher price and another half of the carbon amount. So it's really difficult to kind of make those decisions unless you've got a value for the carbon. And once you've done that, you can also start to calculate the financial impact of all of these decisions together. So you can see every phase we've gone through is essentially an initiative. It might be a design phase, it could just be a design iteration, but you can quantify the impact that each one has. So you can see by replacing the sheet metal with plastic, we've saved around $100,000, reducing the cycle time, saves around 12,000, relocating production 54,000, and green energy around $100. So you can actually start to quantify each initiative. So the return on investment is really nice and clear based on each one. And then I've got one last kind of case study to run through, and this is just looking at pure design changes. So just looking really at the shape. We know that design for manufacturability is a huge contributor towards cost. That also applies for carbon. So what can we do as a pure kind of CAD design engineer? What can we really change? Well, we can change the material, how it's manufactured, and the shape. So we're going to look at that and see how it progresses. So our first version, I'm going to choose an ABS, an all-round engineering plastic. Run it through a priori, we get a cost, we get a weight, we get a time, we've got material and process carbon, and then an annual carbon. So then what we've done is change the geometry very slightly to make it's automatically animating itself, sorry about that. So we've got a second version where we've kind of thinned the walls out, we've kind of put a shell in there to make it a little bit easier to manufacture. It's reduced the cost a great deal. It's reduced the weight by about 20%. The cycle time has gone down, as you might expect with the thinner walls, and the process and material carbon's gone down as well as the annual carbon. Then we can change the geometry again to a third version where we've kind of tweaked it and looked at other design for manufacturability issues. The weight's around the same, the cycle times come down, and it's brought all of the carbon down significantly. So just by changing the geometry, we haven't, oops, sorry about that. Just by changing the geometry, we've actually pretty much halved our carbon and our cost. And all we've done is change the geometry. We haven't changed the process or the material. Because we're with Enginsoft today, we're manufacturing everything in Italy. So then we can look at different materials. So same design for different materials. You can see the weight's gone up, the cost's gone up, the material carbon's gone up, but the process carbon's gone down. So because of the cycle time's faster, the process carbon's gone down, but overall the annual carbon's gone up. So nylon 6 may not be the best for this design. If we go to an acetal, the cost's gone down, the weight's gone up by 10% from the original. The cycle time's around the same as nylon, but everything else has gone down from the nylon. And then the last version, if we choose a PBT, we can actually get the optimum result for this at 86 euro cents and our lowest carbon figure yet. So just by changing the geometry, we've made a 44% saving on carbon, 62% saving on cost. If we change the geometry and the material, we've ended up with a 56% carbon saving and a 74% saving on cost. So hopefully that shows you that balancing cost and carbon is possible. A more sustainable design doesn't have to be a more expensive design. And a priori is just a great co-pilot for helping you make those decisions. Beyond that, using our analytics, you can identify opportunities. So everything you run through a priori goes into our analytics engine, where we can start to identify particular parts that have got high material footprints or low process and low material footprints, or where should you focus? It's probably going to be on these components, and then work your way down. So sustainability with a priori, it's much faster and much more precise than any other method because we're using the 3D geometry and simulating the manufacturing process really, really precisely. And we give you actionable insights so you can make trade-offs between cost and carbon, but ensure you've got manufacturability. And all of the calculations that are used and to come up with these results are transparent, they're configurable, and they're proven. As you saw with the customers at the beginning, they're really basing their business on the results that come out of a priori. So just to summarize today's session, we really help to plug that lack of knowledge by giving you insights all the way through the product development process. And we calculate it from a bottom-up, very detailed carbon assessment. Business model, we really can automate the whole process, so it reduces demand on any internal resources and tries to spread the knowledge and gives people access through our collaboration tool of AP Workspace. The sustainability team can then focus on where they're strongest. They can also be involved as one of the stakeholders through our collaboration tools. But it really takes the design and manufacturing off their hands, and the data that's in a priori goes straight to the design and sourcing teams. And allows them to focus on the regulation and reporting pressures that they've got, and they can obviously leverage all of the calculations that come straight out of a priori. So that brings me end of today's session, but I'm more than happy to answer any questions. We do have a web page on our website on apriori.com, which has a range of manufacturing guides. So if you want to learn more and see some more examples of how you can use a priori to drive down cost and carbon in particular designs for different processes, we also have a sustainability guide and a whole range of other manufacturing guides to take a look at. If you want to reach out to us, you can at hello@apriori.com, but the Enginsoft team is also there to help you along and help you learn more if you need to. So do we have any questions in the Q&A box yet?